Hey everyone, welcome to my channel. In this video we will create a face filter using OpenCV. We will first detect the face and then its landmarks, which will allow us to extract individual features such as eyes, nose, lips and more. From there we will overlay our desired color to the lip feature. I upload videos on a weekly basis, so don't forget to subscribe and hit that like button if you found this video useful. So let's get started. The first thing we will do is to import our libraries, and the main library that we will be using today is known as dlib. Now the dlib library is basically a toolkit that contains machine learning algorithms. So what we will do is we will use this to detect a face, and then we are going to detect facial landmarks within this face. And later on we will extract the lips and we will color them in a different color, and we will convert it into grayscale, and we will see how we can do this on an image and how we can do this in real time using a webcam. So let's import our libraries first. So we will go to File, we'll go to Settings, and we'll go to the interpreter, and over here we will add dlib. We will also add OpenCV, and there you go, we have installed them, and now we have the NumPy automatically as well. So we will go back and we will import these three libraries. So we'll say import CV2, then import NumPy as np, and then we are going to import dlib. Now the first thing we will do is to import our image, and you can see here in my main directory I have 1.jpg, and you can see this is the image which we will be using. So let's import that. Now this image is actually quite large, so we are going to scale it down. So we will write img is equals to cv2.resize, and we will use our main image, and then we will not define any pixel size. Instead we are going to define the scale. So let's put it at 0.5 and 0.5. Then we will make a copy of this. So we will say img original is equals to img dot copy, and then we will display this. So cv2.imshow, window name we can write original, and then we can write img original, and then cv2.waitKey at 0. So let's right click and run, and there you go. So this is the original image, and we have scaled it down. Now the next step is to find our face. So to find the face, we have a frontal face detector in our library. We are going to use that. So we will declare detector equals to dlib dot get frontal face detector, and before sending in an image to this, we are going to convert it into grayscale. So we are going to say img gray is equals to cv2 dot cvt color, and then img, and then cv2 dot color bgr to gray, and then we can simply send faces is equals to detector, and we can send the image gray, and this will store all the faces that it has detected in the variable faces. So next we can create bounding boxes around all the faces that we have detected. So we can write a for loop. So for face in faces, we can say that x1 and y1 is equals to face dot left. So this is the method which will give you the left point, and then you have face dot top, and then you have x2 and y2. Here we will write face dot right and then face dot bottom. Now we can use these values to actually create our bounding box. So we will say img original is equals to cv2 dot rectangle, and then we can write img our image and then x1 and y1. Then we have x2 and y2, and then we have our color. So let's put 0, 255 and 0, and then we will put the thickness as 1, or should we put more? Let's put it as 2. So if we run this now, it should display, yes, so here it displays our bounding box around our face. So now that we have our face, what we can do is we can detect the facial landmarks on this face. So now for that we need a predictor. So we are going to go up here and we will write here predictor. Is this spelling correct? Anyways, so predictor is equals to dlib dot shape detector, shape predictor, and inside that shape predictor we have to send in a file. Now we already have the shape detector file for 68 landmarks on the face. We also have a file for 5 landmarks. So based on your requirement, you can change that as well. So here we will write shape underscore, or maybe I'll just copy this. So this creates our predictor, and now we have to give it an image and then the face object. So here we can go and we can write landmarks is equals to predictor, and then we are going to send in our gray image and then our face. So this will find out all the landmarks on our image. So now that we have all the landmarks, what we can do is we can draw these out on our original image so that we can see which of these landmarks represent which of the features. So to do that, we can loop through our 68 different landmarks. So we can write for n in range 68. So we will say that x is equals to landmarks dot part n dot x, y is equals to landmarks dot part n dot y, and then we can simply write cv2 dot circle, and we will do it on the original image, and we will put x and y as our center point, and we can give it a radius of 5, and we can give it a color of, let's say, 50, 50 to 55, and then we can fill them up. cv2 dot filled. So let's run it. And there you go. So now we can see that we are getting all our landmarks that we have detected. And you can see even the right eyebrow, you can see here, it's not quite visible, but it can estimate where the eyebrow is, and it's pretty accurate in terms of that. And you can see you have the jawline, you have the lips and the nose and the eyes. So next we need to find out which landmark represents which feature. So which landmark number is this? Which landmark number is this? So we need to find that out. So in order to do that, what we can do, we can simply write the number of our landmark next to our landmark point. So we can say cv2.putText, and we will give it our original image, and then we are going to write string of n, which is our number, and then we are going to give it the location x, and for y we want it a little bit higher than the point, so we will put -10, and then cv2.font, we will put which one, any one of the fonts, and then we will put a scale, then a color. So let's put red, and we will give a thickness of 1. So let's run that, and there you go. So now we can see that we have all the numbers as well. So we can see that the jawline starts at 0 and it ends at number 16, and the left eye starts at 36 and it ends at 41. Same way we have 17 till 21, 22 till 26, and so on. So our lip is basically from 48 to 60, and inside we also have a place for opening of the mouth, and that is from 61 to 67. So because we are starting from 0, that's why we have till 67, because we have a total of 68 landmarks. So now that we have our landmarks and we have our face, the next thing we can do is we can separate these features. So we can separate our eye, we can separate our nose, lips, and we can create separate images out of these. So before we actually do that, what we want to do is we want to put all of these X and Y points in one list so that it will be easier for us to manage. So we can write my points is an empty list, and each time we are going to loop, we are going to add my points dot append, and we will append X and Y. So now we have a list of my points which will have all the 68 points. If you want, we can print that out. So let's write print my points, and let's see. So there you go. So we have each point X and Y, and this will be all the way till 68. So how can we actually crop our image? So because we have many different features, we have the eye, we have the nose, we have the lips, we don't want to crop again and again repeating our code. So the best idea would be to create a function at this point in which we can just input the image and the points, and it can output us an cropped image. So let's write our function. Let's bring this down, and this is our detector, and here we are going to define our function. So we are going to say that create box, and inside that we are going to send our image, and then we are also going to send some points. For now we will just put pass, and let me show what we will do next. So let's say that we wanted to crop our eye. Now you can see that we have 1, 2, 3, 4, 5, 6 different points that actually give us the location of our eye. But how can we create a bounding box around this? what we can do is we can estimate the region where the eye is based on our given points. Now we have a function in OpenCV to do this. So what we will do is we will get our points, and the first thing we will do is we will create a bounding box. So we will say bounding box is equals to cv2 dot bounding rectangle, and we will input our points, and based on these points it will give us 4 different points that will give us our bounding box. So we will say that x, y, width and height is equals to our bounding box. So next we will crop our image. So image crop is equals to our main image, the one that we have received, and then we are going to crop it. And to crop it, first we have to define the y. So we will say from y till y plus height, and then x till x plus width. So this will give us that region, and then we can what can we do now? The thing is, this image will be very small, so it will be hard to see and it will be hard to move around. So what we can do is we can resize it. We can say image crop is equals to cv2 dot resize, and image crop, and then we are going to resize it based on the scale. So let's resize it. Let's say, actually let's give the user the option to decide the value. So we can give a default value as well. So we can write here scale is equals to, let's say 5, and then the user can change if they want. And at the end of the day we need to return our image. So return image crop. So once we have our face and we have the my points list, we can apply this function. So over here, let's say we want to get the left eye, so we can write image left eye is equals to create box, and we will send in our image, so img, and then my points, and my points for the left eye are from 36 to 41. So we will write 36 to 42 because 42 is excluded, so we have to write till 42. And then what can we do? We can show it, so we can write cv2 dot imshow, and we can say left eye and image left eye. So let's see if that works. And we have a problem. Yes, we need to convert it into a NumPy array. So we have this as a list. Before we send our points, we need to convert it into a NumPy array. So here we will write, it's very simple, we will write my points is equals to numpy dot array my points. So there we have it. So what we need to do is we need to remove all these points. So where are these points? So and there you go. So now we have our left eye cropped and in a separate image. So the same thing we can do with the other points. So for example, we are going to color the lips, so let's grab that. So we can write for lips it is from 48 to 60. So let's comment this out. So we can write here image lips is equals to create box, and we can write no, we can write the image and then our my points from 60, what was it, 48 to 61. And we can display the ellipse, and there you go. So now we are getting only the ellipse. Now, as I mentioned before, you can give it a custom scale. So for example, if we don't give it any scale, if we put it as 1, then you can see it will be very small. You can see the image is very small. So that's why we are giving it a scale. So maybe 3 is good. And there you go. So now you have the lips here. So now we are getting our feature such as the eye or the lips as a rectangle. And that is good if you want to extract those features, but if we want to color them, we need the exact location. We cannot have a rectangle. Instead, we need a polygon. We need the exact points of our lips or the eye. So what we can do is we can add a little bit of functionality to our create box function, so that we can get a polygon rather than a rectangle. So let's go to our create box. So here we can add the option of a masked image rather than a pure rectangle. So in order to do that, we have to first create an image like our original image, but in black color. So we will say mask is equals to numpy.zeros, and we will say they should be like our original image. And then we are going to put our feature in this mask. So we are going to create a polygon, and we will fill that with some color. And that color we will use is white. So now we will draw our feature in this mask, in this image. So we will write mask is equals to cv2 dot fill poly. Now, because we are not talking about rectangles anymore, we want to fill the exact points. That's why we are using fill poly. So we will fill it in our mask, and the points that we have, we will send them in, and then we are going to give it a color. So our color is 255, 255, and 255. So this will give us white color. So let's just display this first. So we will write cv2.imShow, and we will write mask and then mask. And there you go. So this is basically our mask. So if you look at this image and this image, they are exactly the same size, and it's just giving us white region wherever it has found the lips. So that is good. So the next thing we will do is we need the actual lips. We don't need just the white color region. We need the actual colors. So what we can do is we can do a bitwise AND. So we will say that our main image is equals to cv2.bitwise and then we will merge these two images. Those will be image and the mask. So if we run that, so basically what we are doing is we are adding this image to this image, and that should give us only the region where we have this white region, which is our lip. And there you go. So this is what we are getting now, but this is after the crop. Let's look at it before the crop. So we can just bring this down here, and we can write image. And there you go. So this is what we are getting now. So this is our main image now. So before we were cropping from the original image, this time around we will crop from our mask image. So when we crop that region, we will get this. Now this is automatically being done because we already wrote the code for cropping. So this time around, we are not getting any of the details around our lip. We are only getting the lip region. So this is now useful to us because we can simply take this region and color it out. Now a few more things we can add because we don't always want to do this. We can add the option of masking or not masking. So we can write here masked is equals to false. So we will not mask by default. And we can also add the option of cropping. So cropped is equals to true. So by default we are going to crop. So this we will, let's remove this, or let me just comment this out. And these are the two regions. So the first region we will write if masked, then we will perform this. And then we will write over here that if cropped, if we want to crop, then we will do this. And if we are not cropping, then we cannot send image crop. Then we have to send our other image. So we will say else return mask. So let's try that out. So here we are going to say that masked by default it's false. So if we do by default, it will give us the bounding box, I believe. Yes, so it's giving us the bounding box. So if we say masked is equals to true, this will give us the masked region. Yes, that is true. And if we just want without the crop, we can say cropped is equals to false, and that should give us the complete image. There you go. So that's giving us this, and it's only giving us the region, the real mask that we will use later on. Now using this functionality, we are going to color the lips. So to do that, we need to define a color, and then we can merge these images together to actually get the final output. So first we need a color. So the idea here is that we are not going to crop our image, and we are going to mask. So if we run this, so the idea is to color this region with whatever color that we require, and then we will merge these two images together to give us the final output. So first thing is to color this. So how can we color only in this region? So we have used this technique before in our function, and we are going to do that again. So first we are going to create a new image. So we will call this image color lips is equals to numpy dot zeros like, and we are going to image lips. So this will give us a black image, and what we need to do is we need to change the color of it. So we will write img color lips, and we will say to the complete image we want to change the numbers to 153, 0 and 157. Now this is for purple color, and whatever color you desire you can write here. So this is B, this is G, and this is R. So blue, green and red. So let's just output this first. So let's copy this here, and we will write here, and we can say lips. Why does this say left eye? It should say lips, and here we can say lip. Is it lips? No, it's the colored image. So colored. So let's run that, and there you go. So we are getting the purple color image of this size. So now what we can do is we can use Bitwise and to actually add these up. This black image with the mask plus this purple color. So when we add those up, it will color this region with purple. So let's do that. So we can write here img color lips is equals to cv2.bitwise and we need to do it for our image lips and then image color lips. And there you go. So now we are getting a black image with only the lip region colored to our desired color. So now what we can do is we can add these two up. We can merge this image, the original image, and this image up. We can add them up, and that will give us the colored lip region. So let me remove the rectangle first. And yeah, it's removed. So before we actually add them up, we are going to add a little bit of blur, because at the edges, if it's too sharp, it will not look very natural. So if it's faded out, it will look more natural. So we can write img color lips is equals to cv2.gaussian blur. Where is it? Gaussian blur. And then we are going to apply it to our colors and color image, and then we will write the kernel size 7x7 and we will give it a sigma x. So you can change these values if you want to change the effect a little bit more or a little bit less. Now the last step is to add them up. So we will use img color lips is equals to cv2.added weight. So this will add them up based on their weights. So the first image we want complete, so we will write img original and we want it complete, and then we need the second image. Now this you can add based on your preference. I found 0.4 to be a good value, and let's see how that looks. And there you go. So now we have our colored image, which basically applies the color on the lips. So next we can convert this into grayscale and just color the part of the lips. So to do that, we need to introduce the grayscale image. So we will write here img original gray is equals to cv2.cvt color, and we will send our original image original, and then we will say cv2.color bgr2 gray. And now we have converted it into gray, but we have to convert it back to colored image. And the reason for that is because we are actually getting the final image as a 3-channel image, because we want to show that purple region, that purple color. The final image has to be 3 channels. So we will just copy this and we will say that our image gray is converted back to gray to BGR. So if we run that, oh, I need to change that image gray. This time we will add it with that. And there you go. So now we have that gray image and we have only the lip region that is colored. Now if you did not understand this part, let me show you. So if I remove this, let's see what happens. There you go. It will give us an error. because the size of the images, they don't match, so we cannot add them up, because one image is only grayscale, which is one channel, and the other image is of three channels, which is BGR. So to add them up, we have to convert it back to three channels, which is colored image. So here we have our final image. Now the last thing we can do is to add the option of changing the color. So to do that, we can use Trackbars. So we have to initialize our trackbar. So we can write here cv2 dot name the window, and we can write this as bgr, and then cv2 dot resize window. We will write here bgr, and then 640 by 240, and then we have to create three track bars for blue, green, and red. So we will write cv2 dot create track bar, and this will be blue, and we will put it in the bgr window, and we are going to give it an initial value. Let's give it 0, and then the final value, which is 255, and then the function that will be called. So we can write here empty, and we can create a function here by the name empty, and we can just say pass. So there we go. And then if I paste this 3 times, we can change this to green and then red. And down here we can write, over here we can write BGR, because we want the track bar to be in the same image. So let's run that and see if it's correct. There you go. So in the grayscale image we are getting our track bars, but nothing is happening. So we will go, what is this? The argument. So just put an A here. Okay, so now we need to use the values of these track bars, and we will replace them here. So how can we get the value? So we can write b is equals to cv2 dot get track bar, get track bar position, and then we will say we need the blue one, and it is in the BGR window. And then we can copy this twice, and we will write here green, and then red, and we will write here B, G, and R, and we will replace this with B, G, and R. So if we run this, so now you can see we don't have any color. If we move it around, do we have any colors? No, we don't have any colors. Why don't we have any colors? Oh yes, I forgot to add the while loop. So we have to create a while loop to actually run this, and the while loop should be here. While true, we will do all of this, and we will put this as 1. So let's move that, and there you go. So now the color of the lips, they are changing. So if we wanted red, we will put the green and blue 0, and we will just change the intensity of the red. So you can see here. And then if we wanted blue, again we will just change the intensity of the blue. Now, since we have already added the while loop, you can add the functionality of using a webcam. So to do that, we can right here, we can give here an option of webcam is equals to true. And over here, we can write cap is equals to cv2.video capture, and we will capture device number 0. Here in the while loop, we can write if webcam success and image equals to cap dot read, and else we will take the image. So my webcam is connected. Let me open up this image, and if I run it now, oh, there is an error and the resizing. I think my webcam is also being used somewhere else. Let me plug that in again, and if I run it again, yes, that was the reason. So okay, the scale is very small, so let's increase that. Let's put it as 1:1. So there you go. So you are looking at the screen here, and what I can do is I can open up my image, and now you can see that this is the original image detecting, and this is the image with the color. It's a little bit confusing the way it's going on. Let me put this one here. Okay, so now you can see that we are able to change the color here as well. With the webcam, you can add the real-time functionality as well. Again, this is on a screen, that's why it's a little bit faded. If you use it on an actual image or a video, it will be much more clear. So this is it for today's video. I hope you have learned something new. If you like the video, give it a thumbs up, and don't forget to subscribe to keep getting the latest updates. I'll see you in the next video.